Analog Chebyshev low pass filter. Analog Chebyshev low pass filter. Okay. Now, this analog Chebyshev low pass filter is a two type. That is your type 1 filter and a type 2 filter. Okay. Now, how you can categorize this type 1 and type 2? Just I will explain. Let's see. Now, this is the magnitude of Chebyshev filter. HA, J omega magnitude. This also J, J omega magnitude. This is 1 del P. Okay, tell us I will write it. Now, what is type 1 filter? Simple, I will explain. Say, in type 1 filter, there is a ripple in the pass band. There is a ripple. See, these are the ripples. There is a ripple in the pass band. And monotonic in the stop band. So this is your pass band and this is your stop band. This is LS 0 omega P omega S omega. Okay. Now if you say in the type, this is your type 1 filter. In the type 1 filter, what I said, say simple ripple in the pass band. These are the ripples. Ripple in pass band and monotonic nature. This is monotonic decreasing. Yes or not? Monotonic in the stop band. This is your stop band. So it's monotonic in stop band. Okay, clear? So type 1 Chebyshev filter having ripple in the pass band, and where this ripple will start, that I will discuss later. Don't worry. And monotonic characteristics in the stop band. But in case of type 2, simple it is opposite. Type 2 Chebyshev filter. In the type 2 Chebyshev filter, it's just opposite. Opposite means what? It's a monotonic in the pass band and ripple in the stop band. I will show you. See, it is a monotonic nature in the pass band, means monotonic decreasing in the pass band and ripples in the stop band. Okay, see. So this is your omega S. This is your 1. Okay, so say this is a monotonic in the pass band. Okay, and ripple in the stop band. So in this way, we will categorize this Chebyshev filter into two types. Okay, type 1 Chebyshev filter and type 2 Chebyshev filter. In the type 1 Chebyshev filter, what I explained that is a ripple in the pass band, and where this ripple start, we will discuss later. It will not start 1 or it will not start del P. It depends upon the order of the filter that we will discuss later, and monotonic behavior in the stop band. But if you see type 2 Chebyshev filter, it is a monotonic in the pass band and the ripple of the nature of the characteristics in the stop band. So what we will discuss in our syllabus, that is only type 1 Chebyshev filter. We will not discuss type 2 Chebyshev filter. Okay, now come to type 1 Chebyshev filter. Now type 1 Chebyshev filter. Okay, the magnitude response of type 1 Chebyshev filter given by h of j omega square equals to 1 by 1 plus epsilon square cn square omega by omega p. Okay, so this is your magnitude square of type 1 Chebyshev filter, like your Butterworth filter. Okay, so here two terms are there. One is epsilon, another is cn. Okay, now this epsilon is parameter related to ripple in the past. Okay, this epsilon is the parameter related to ripple in the pass band. And what is the Cn? This Cn x. X means omega by omega p here. Just time difference Cn x. It is a Chebyshev polynomial. Chebyshev polynomial. And it is defined as Cnx equals to is a cos of n cos inverse x if mod x is less than 1 and cos hyperbolic and cos hyperbolic inverse x if mod x greater than 1. So in this way, we can define this Chebyshev polynomial. You have to remember, okay, Cn x equals to cos of n cos inverse x if mod x is less than 1. Mod x less than 1 means what? What is x here? X is omega by omega p, yes or not? That is, we can say that omega by omega p, it is less than 1. So that is what? Omega less than omega p. Obviously, omega less than omega p means it is a pass band, yes or not? So, similarly, if mod x greater than 1 means I can say that omega by omega p magnitude greater than 1, that is omega magnitude greater than omega p. Obviously, what? This is stop band, yes or not? After pass band, it is stop band, and this is your pass band. Okay. Now this is your Chebyshev polynomial. We can define in this way. Clear? Now I hope you all people understand. This epsilon is parameter related to ripples in the pass band, and Cnx is the Chebyshev polynomial. It is very important. And this h j omega square magnitude square is the what magnitude response of type 1 analog Chebyshev low pass filter. Okay, Chebyshev low pass filter. Low pass filter it is. Okay, now we will discuss more about this Chebyshev polynomial. What is this Chebyshev polynomial? See, now since we know that for the type 1 the ripple in the pass band, so what I will do, just I will take like this Cn x equals to cos of n cos inverse x. Okay, now what is C0x? Put n equals 0. What is the value of C0x? Anyone? What is C0x?
1.
1. Good. It is cos of 0. Cos 0 means it is 1. Okay. Now what is C1x? It is cos of cos inverse of x that is equals to x. Yes or not? Now, similarly, we can find C2x, but to find the higher order, we will process like this. So, what you got? We got C0x equals to 1 and C1x we got equals to x. Now, to find the higher order Chebyshev polynomial, let I will do like this. Let cos inverse x equals to theta. Then it is x equals to cos theta. Okay. Then cos of n theta plus cos of n minus 2 theta. Cos c plus cos d to cos of c plus d by 2. C plus d by 2 means n minus 1 theta multiply cos of c minus d by 2. That is n theta minus n theta plus 2 theta by 2. That is equals to theta. Okay. Now what is your CNX? Your CNX is cos of n cos inverse x. Yes or not? Now see, cos of n theta means what? This is your cos of n theta because cos inverse x equals theta I taken. So what I can write? Cos n theta means your CNX plus cos of n minus 2 theta. Same way, it is C of n minus 2x equals to 2. This is your C of n minus x multiply this cos theta is x. So what it got? Finally got here cnx equals to 2x c of n minus 1x minus c of n minus 2x. Now I will use this equation to find the value of Chebyshev polynomial for a higher value of n. Okay. Now C0 x C1x is known to us. Not to all. What is C2x? Now use this equation. Let this equation one. Put n equals to 2. C2x equals to 2x C1x minus C0x. That is 2x. What is C1x? X minus C0x is 1. That is equals to 2x square minus 1. Similarly, C3x equals to 2x C2x minus C1x. Yes or not? Simple. Put n equals to 3 in the equation 1. Then what will we get? It is 2x. C2x is 2x square minus 1 minus C1x is x. It is your 4x cube minus 2x minus x minus 3x. Okay. Same way find C for x. C for x equals to 2x C3x minus C2x. So 2x C3x 4x cube minus 3x minus C2x 2x square minus 1 equals to 8x4 minus 6x square minus 2x square plus 1. That is 8x4 minus 8x square plus 1. Yes or not? Similarly, if you want, you can find C5x, C6x like this. Now, from this, I want to take some observation. What observation? Say, if you see this, means C0x, C1x, C2x, C3x, C4x, what you observe that Cn minus x equals to Cnx if n is even. Yes or not? See, C2x equals to 2x square minus 1. So C2 of minus x, same. 2x square minus 1 only. Okay. C for x, 8x square minus 8x square plus 1. If you find C for minus x, you will get same thing. Yes or not? So Cn minus x equals to Cnx if n is even. Okay. Similarly, Cn of minus x equals to minus Cnx if n is odd. Okay. Now you take the odd part. Odd part means C1x. Then if you want to find C1 of a minus x, it is a minus C1x. Yes or not? Similarly, you take C3x. If you find C3 of a minus x, see all are odd power, obviously we get minus a C3x. Okay. So what you got? Cn of minus x equals to minus Cnx if n is odd. Then what is the value of Cn0? If you see all this, Cn0 equals to 0 if n equals to odd. Yes or not? See, C1 0, 0, C3 0, 0. Similarly, if you find C5 0, also get 0. And Cn0 equals to plus or minus 1 if n is even. Check it. If you check here, say C0 0 is 1. What is the value of C2 0? C2 0 is minus 1. What is the value of C4 0? C4 0 is plus 1. Okay. So if same way if you do, then what you got? Cn 0 equals to plus or minus 1 if n is even. Okay. These are all properties of Chebyshev polynomial. Similarly, Cn 1 equals to 1 for all value of a capital N. Now put here C1 1 1. What is C2 1? If you put C2 1 means 2 1 square minus 1 1 only. C3 1. C3 1 means 4 minus 3 1. C4 1 8 minus 8 plus 1 it is 1. So Cn1 equals to 1 for all value of n. These are some important observations. Important observations of Chebyshev polynomial. Can you not? It's very simple. Now, if you see, then we got all this property that is Cn minus x equals to Cnx if n is even. Okay. And Cn minus x equals to minus Cnx if n is odd. Cn0 is 0 if n is odd. See, there is no confusion, just put the value. Already equations I written here. Okay. To satisfy, put the value. Okay. Similarly, Cn0 equals to plus or minus 1 if n is even. And Cn1 equals to 1 for all value of n. These are some important observations of Chebyshev polynomial. Or you can say that these are the properties of Chebyshev. Okay, polynomial. Clear all of you? Yes or not?
Yes, sir.
Okay, it's very simple. Just I given all this. Okay, now what I will do in the previous slide means what I said that the type 1 Chebyshev filter is ripple in the passband. Yes or not? I said to you people, this type 1 Chebyshev filter having a ripple in the passband, but where this ripple will start, we will discuss later. I said at that time. Now we will say where the ripple will start. Okay, this was completed or any doubt? If doubt you ask me. I will give you 30-second time. If anyone having doubt, you can ask me. Otherwise, I can move to next. Okay, means no doubt. Clear? Now see. Okay. Now, what is our equation? Our equation is HA j omega magnitude square is 1 by 1 plus epsilon square Cn square omega by omega p. Okay. Now see. Now, first take the condition for even. Let n equals to even. Okay. N equals to even. We will see where the ripple will start. This one. Okay. del P. Del S 0 omega P omega S. Okay. Now, if n is even, what you got? N is even, and if you see exactly at point 0, because you want to know when omega is 0, where the ripple will start. Okay, n is even, and we'll see the starting point omega equals to 0. Okay, then what is H j omega square? H j omega magnitude square is 1 by 1 plus epsilon square cn square 0 by omega p, that is 1 by 1 plus epsilon square cn square 0, that is h of j omega magnitude square. Then what is cn 0? If you see this, say this cn 0 equals to plus or minus 1 if n is even. Yes or not? Cn 0 is plus or minus 1 if n is even. Now what I will do? Now see here n is even, so it is equals to 1 by 1 plus epsilon square, it is plus or minus 1 whole square. Okay, that is your h of j omega magnitude square equals to 1 by 1 plus epsilon square, or h of j omega magnitude is 1 by square root of 1 plus epsilon square. This is very, very important. Okay, means I will show you here. Now where the ripple will start, because this is for omega equals to 0. Yes or not? Omega equals to 0. So where the ripple will start? Ripple will start at 1 by root over 1 plus epsilon square. So this is your 1 by root over 1 plus epsilon square. Okay. So the ripple will start from here. This is very, very important. Now the ripple will start from here. Okay, say, so this ripple will start to 1 by root over 1 plus epsilon square. This is very, very important. And what you observe one thing, that at this point also, always remember that del P equals to 1 by root over 1 plus epsilon square. Okay, because I taken this passband attenuation as del P, same like your Butterworth filter, the del P equals to 1 by root over 1 plus epsilon square. The important point is when n is even, the ripple starts at 1 by root over 1 plus epsilon square. This is very, very, very important. Now, the where the ripple will start, that will decide by the factor epsilon. Okay, that's why I say that epsilon is a parameter. If you see in the first one, I said epsilon is a parameter related to ripple in the passband. Means the ripples in the passband depends on the value of epsilon. Okay, clear all of you? So this is a what? This is a Chebyshev filter response for n is even. Okay, this is for n is even. Okay, similarly, we can see for n is odd. Okay, now can you suggest me how can do for n is odd? If you take n is odd, just okay, we'll see in the next step, not here.
Excuse me, sir.
Ah, yes, yes.
Sir, yeah, that 1 by root over 1 plus omega, that value del at del of p1, it will start. How can you say, sir? Del of s.
No, no, this is actually initially to see this. So many books, they starting with this. Means they taken instead of del p, they taken like this root over 1 plus epsilon square. Okay, if you see maximum book, they taken like this. But instead of taking like this, first initially I taken this parameter. After that, means what? At that time I said that where the ripple will start means it is in between 1 to del p. Okay, but I not given this notation intentionally. But what I did, when just it is coming at 1 by root over 1 plus epsilon square. I assign that value to del p. Okay.
Yes, sir.
This is the notation given in almost all book. Okay, and this is what say reverse means what? Reverse means it is a simple. You can say that it is a attenuation. Yes or not? Agree or not? Because
Yes, sir.
say you people should be clear why it is known as ripple. Because the magnitude response must be equals to one value. Yes or not? If it is one, then only the signal will pass. No? Or doubt? Hello. When it is 1, then if you pass a signal randomly, let this is a signal. When you multiply this filter response, then this signal multiply with 1 first class, remember. Then only the signal will pass, no? Yes or not? Hello? Hello?
Sir.
First class, just remember, I already explained this part. Say, what the meaning of filter already explained. This is a signal. When you are passing through a filter means, say, what happened? The filter is like this, then the magnitude response is 1. Then what is happening? Simple, it is a multiplication, yes or not? Because let this is the signal x of t, let this is your filter response h of f. Actually, what is happening? Y of t equals to x of t convolution of h of t. Already I explained in the first lecture itself. Okay, this is x of t, this is a y of t. So y of t equals to x of t convolution of h of t. Then what is y of f? Y of f equals to x of f multiply h of f. So this is x of f multiply this is h of f. Then what is happening? Now if you want to pass the signal in the frequency range of f1 to f2, then the magnitude from range f1 to f2 must be equals to 1. Then only when you will multiply, then what will happen? This is 0, this is 0. 0 multiply this portion means what will happen? This portion become vanish. Similar, this is 0, multiply this portion means this portion also vanish. So what will get? At the output, simple will get like this. Yes or not? Okay. Means when the magnitude equals 1, you are getting the same signal. Now what we are doing here, we are taking some ripple. Means what the meaning? Instead of this, you are taking the values like this. Then what will happen? You will not get this exact signal, yes or not? Because see, now instead of 1, the value is varying. Yes or not? See, these values are varying. Sometimes maximum value, sometimes minimum value, and sometimes in between maximum and minimum value. So what will get? You will not get this exact signal. Yes or not, Akhil?
Yes, sir. Yes, sir. Got it, sir.
But no, this is the simple concept. That's why it's known as a ripple. Ripple at the pass band. But actually you want one. But the Chebyshev filter having ripples in the pass band. Okay. And this ripple depends upon this factor epsilon. That's why the ripple in the pass band I taken 1 by root over 1 plus epsilon square. Correct?
Yes, sir.
Okay, fine. Now we'll see for this n equals to even is over. Now what to do? Next condition. Next condition is let n equals to r. Then what will happen? If n equals to r, same again the magnitude response is h of j omega magnitude square equals to it is 1 by 1 plus epsilon square cn square omega by omega p. Now n equals to r and omega equals to 0. Obviously omega equals 0 because we want to know the starting point of the filter. Yes or not? Okay. See, this is 1 by root over 1 plus epsilon square. See, again I want to repeat. If you people confuse, then starting itself you take this. If you people are confusing in the diagram, starting itself you instead of del P, you take like this. Okay, no problem. Okay, now this is your 0, omega P, omega S. This is your omega. Okay, this is a response HA, J omega magnitude. Now say this omega equals to 0 and n is odd. Now what is the value of C and X if n is odd or C and 0? Because omega equals 0, now first we'll put, no problem. That is HA, J omega magnitude square equals to 1 by 1 plus epsilon square Cn square. Since omega equals to 0, it is a 0. Now here n is odd. What is the value of Cn 0 when n is odd? Yes,
Zeros.
it is a 0. Then it is a H j omega magnitude square equals to 1 by 1 plus epsilon square multiplied 0. This is a simple 1. Okay, it is simple 1. So what I can say that when n is odd, it is not starting from 1 by root over 1 plus epsilon square. It is starting from 1. This is very, very important. The ripple will start from 1 like this. Okay, now say here it is starting from 1. So this is for n equals to r. This two thing is very, very, very important. Okay, so when n is odd, the ripple starts from 1, and when n is even, the ripple starts from 1 by root over 1 plus epsilon square. This 2 point is very, very important. Why it is important? When you will find the transfer function, obviously when n is even, then the transfer function will multiply with 1 by root over 1 plus epsilon square. Yes or not? Because the ripple is starting from here. Similarly, if n is odd, then no problem. The transfer function will multiply with the 1. Okay. So it is very, very important. When I will do the derivation for transfer function, I will again use this concept there. When n equals to odd, while finding the numerator, I'll put omega equals to 0, and I will multiply with 1, and when the n is even, I will multiply with 1 by root over 1 plus epsilon square, and I will put omega equals to 0. Okay. You have to remember these two things. It is very, very important. Okay. Now, all people clear how to find the order of the filter. And here, because if you see here, this epsilon is the parameter related to repellent fast band, CNX is Chebyshev polynomial. Okay, or you can say that nth order Chebyshev polynomial, and simple what is n? N is order of filter, order of Chebyshev low pass filter. Okay, there is no doubt, you know this thing, that's why not written. Okay, now how to find this order of this filter? It's very easy. How to find the order of the filter? Okay, how to find the order of Chebyshev low pass filter? Now, before that, first you just do the diagram so that you get a clear idea how to find the order of the filter. One is 1 by root over 1 plus epsilon square, that is equals to del P. Okay, I'm assigning to HNS in the past when this is your del S. Okay, this is omega P, omega S. Now again, the ripple is starting from somewhere. I'm not putting exactly because it depends upon the order of the filter. Okay, this is our analog Chebyshev low pass filter type 1. Okay. Now what is our equation? Our equation is h of j omega magnitude square equals to 1 by 1 plus epsilon square cn square omega by omega p. Now I will do same process what I did for Butterworth filter. Now at omega equals to omega s, at omega equals this omega na, at omega equals to omega s, and this is your h of j omega magnitude. Then what is h of j omega magnitude? N1. What is the value of h of a j omega magnitude at omega equals to omega s? See this diagram and tell me. It is a yes.
Del S.
Very good. It is a del s. See, at omega equals to omega s, the value is a del s. Yes or not? See. Now, I just use, let this is a equation A. I will use this concept here. That is a del s square equals to 1 by 1 plus epsilon square cn square omega s by omega p. Or I can write like this epsilon square cn square omega s by omega p. It is del s minus 2 minus 1 or cn square omega s by omega p. It is your del s minus 2 minus 1 divided by epsilon square. Then what is epsilon square? Can someone tell me what is epsilon square? 1 by root over 1 plus epsilon square equals to del p, or 1 by 1 plus epsilon square equals to del p square. Then what is epsilon square? Del p to the power minus 2 minus 1. It is del s to the power minus 2 minus 1 divided by del p to the power minus 2 minus 1. Okay. Then what is Cn? Cn omega s by omega p. Simple square root. It's square root of del s minus 2 minus 1 del p to the power minus 2 minus 1. Now can you someone say me what is the value of omega s by omega p? It is greater than 1 or less than 1? Yes.
Greater than 1, sir.
Obviously, let's say the portion of omega is always greater than omega p. Yes or not? Omega is always greater than omega p. So we can say that omega is always greater than omega p, or omega is by omega p always greater than 1. So what formula I will use? Just see the Chebyshev polynomial formula I given. If mod x is greater than 1, then I will use this formula. Yes or not? Agree? Yes or not?
Yes, sir.
Because this is less than 1, so I will use this formula. Now, use this formula. I can write this cos of hyperbolic and cos hyperbolic inverse omega s by omega p equals to square root of del s minus 2 to minus 1 del p minus 2 minus 1. Okay, so like this cos of cos hyperbolic and cos hyperbolic inverse omega s by omega p equals to it is del s minus 2 minus 1 divided by del p minus 2 minus 1. Okay, or I can write like this and cos hyperbolic inverse omega s by omega p. In this cos hyperbolic, I'll take right hand side. It is cos hyperbolic inverse del s minus 2 minus 1 divided by del p minus 2 minus 1. It is some mistake, yes or not? Say, it is square root. This is your square root. This is your square root. Okay. or I can write like this, n must be greater than equals because always order is a higher value, so we should prefer the higher value. N must be greater than equals to cos hyperbola inverse of del s minus 2 minus 1 divided by LP minus 2 minus 1 divided by cos hyperbola inverse of is omega s by omega p. Okay, clear? And what the cos hyperbola formula? Cos hyperbola x equals to ln x plus root over x square minus 1. Okay, you have to use this formula to find the value of order cos hyperbola x equals to ln x plus root over x square minus 1. So in this way, this is your order formula. This is the order formula. I hope you people understand. Listen on how to find the order of the filter. Okay, now you have to use this cos hyperbola x ln x plus root over x square minus 1 to find these values. Now, if del s db equals to minus alpha s and del p db equals to minus alpha p, then again same thing we will do. Then what is del f s? Del f s is 10 to power what? 0.1 del s of minus 1 10 to power 0.1 alpha s. Similarly, del p of minus 2 is 10 to power 0.1 alpha p. Same what it did in the Butterworth. Then put in this equation. Then we can write and greater than equals to cos hyperbola inverse. This is square root of 10 to power 0.1 alpha is minus 1 divided by 10 to power 0.1 alpha p minus 1 divided by cos hyperbola inverse omega s by omega p. Okay, so both formula are given. The first formula, if linear value of omega p and omega s given, and second formula, if the value given in the dB. Okay, if the linear value given, it's not given in the dB, then use this let equation 1 to find the order of Chebyshev low pass filter, and if it is given in the dB, then use equation 2 to find the order of the Chebyshev filter. Clear all of you?
Yes, sir.
Okay, are in doubt? No, no?
Sir, can you go to the previous slide once, sir?
Previous slide. Okay, good. Yes. Where?
I, I didn't note down the last formula, sir. That's why.
Okay. See, how I am giving the derivation set, try to understand the concept so that it is easy to remember. Yes or not? Otherwise, it may be difficult for you to remember the big formulas. Okay. So try to remember this main formula, this main equation, and this diagram. Then you can derive by yourself. It's not difficult. Clear all of you?
Yes, sir.
Okay. Now, this is the formula we got to find the order of Chebyshev low pass filter. Okay, you have to use this one. This is cos hyperbola inverse x equals to ln x plus root over x square minus 1. Here, what is the x means? This inside part is x, or this inside part is x. Okay, don't do mistake. This is the calculator operation, and this is if it is given in the dB. Okay, it is given in the dB. Or if you want to write what del s equals to 10 to power minus alpha s by 20 and del p equals to 10 to power minus alpha p by 20. Okay, then del s minus 2 equals to this. Correct? Already I did in the Butterworth. That's why I written directly, but no problem. Again, okay. Now again, just recall what we discussed today. I will show you here. We started with the analog Chebyshev low pass filter. Okay, we started with the analog Chebyshev low pass filter. This is two type, type 1 filter and type 2 filter. What is the basic difference? In the type 1 filter, ripple in the pass band and monotonic nature in the stop band. While in type 2 filter, it is a monotonic in the pass band and ripple in the stop band, just opposite of type 1. Okay, and as I said that initially I take it del P, but if people are confused, means you can use this notation 1 by root over 1 plus epsilon square equals to del P. Correct, no problem. Okay, after that we just define all the parameters. Okay, what are the parameters? See, this common parameters I now define, like your del P, because you know that's why not defined. That is del P is attenuation, or you can say that ripple, in pass band. Del S is attenuation or ripple in stop band. Then your omega P, your frequency or pass band frequency in radian per second. Omega S is stop band frequency in radian per second. If you want to formula also already said in the previous class, omega P is 2 pi Fp and omega S equals to 2 pi Fs. Okay, clear? Where Fp is the pass band frequency in hertz, Fs is the stop band frequency in hertz. Okay, that is the Fp. Fp is a pass band frequency in hertz. Similarly, your Fs, stop band frequency. Okay, it is a stop band frequency in hertz. And this omega P actually is capital omega S. This pass band frequency in radian per second, and this is the stop band frequency in the radian per second. Okay. Since I define all this parameter in the Butterworth filter, that's why not written. Otherwise, if you want, we can write, no problem. After that, what we discuss about these two parameters, that is very important. The equation represents the magnitude response of type 1 analog Chebyshev low pass filter. Okay, here two parameters is important. One is epsilon, another is CNX. This epsilon is parameter related to ripple in the pass band, and CNX is the Chebyshev polynomial, or you can say that nth order Chebyshev polynomial. Both are correct. Nth order Chebyshev polynomial. Then we define this is equals to cos of n cos inverse x if x is less than 1, or it is cos hyperbolic n cos hyperbolic x if mod x is greater than 1. Then we just find some value c0x, c1x means Chebyshev polynomial value for different value of 1. And to find the higher order value, just I use this equation. First, what I did, cos inverse x, I take n equals to theta, that is cos theta equals x. Then I use this equation, cos n theta plus cos n minus 2 theta equals to this. That is, we got finally this equation, cnx equals to 2x cn minus 1x minus cn minus 2x. By using this equation, we are able to find all the higher value of Chebyshev polynomial. After that, we just discuss some property or characteristic or important observation of Chebyshev polynomial. Okay, that is Cn minus x equals to Cn plus x. If n is even, if n is odd, then the Chebyshev polynomial also odd. Okay, then Cn value at 0 equals 0 if n is odd. Cn value equals to plus or minus 1 if n equals to even. And Cn equals to 1 for all value of n. After that, based on the observation, we derive two parts. If n is even, then the ripple is starting from 1 by root over 1 plus epsilon square. Similarly, when n is odd, the ripple is starting from 1. This is two very important part. Okay, it's useful at the time of writing transfer function or deriving the transfer function of a Chebyshev filter, and at the end, by using this specifications, we just able to find the order of the Chebyshev low-pass filter, and we got the equation like the first equation is order of Chebyshev filter. If you tell us del P given